Model Test 5, Listening Section.
The listening section tests your ability to understand spoken English that is typical of interactions and academic speech on college campuses. During the test, you will listen to conversations, lectures, and discussions, and you will answer questions about them. This is the long format for the listening section. On the long format, you will listen to 3 conversations, 3 lectures, and 3 discussions. After each listening passage, you will answer 5 to 6 questions about it. Only 2 conversations, 2 lectures, and 2 discussions will be graded. The other passages are part of an experimental section for future tests. Because you will not know which conversations, lectures, and discussions will be graded, you must try to do your best on all of them. You will hear each passage one time. You may take notes while you listen, but notes are not graded. You may use your notes to answer the questions. Choose the best answer for multiple-choice questions. Follow the directions on the page or on the screen for computer-assisted questions. Click on Next and then on OK to go on to the next question. You cannot return to previous questions. The listening section is divided into sets. Each set includes 1 conversation, 1 lecture, and 1 discussion. You have 10 minutes to answer all of the questions for each set. You will have 30 minutes to answer all of the questions on the long format. A clock on the screen will show you how much time you have to complete your answers for the section. The clock does not count the time you are listening to the conversations, lectures, and discussions.
Listening 1, Professor's Office.
Listen to part of a conversation between a student and a professor.
Professor Collins, I'm really sorry. These are my daughters. They're twins. I wouldn't ordinarily bring them to an appointment, but the babysitter didn't show up, and I couldn't leave them. I didn't want to cancel. I hope it's okay.
It's okay. I have 3 kids of my own, and I've been in the same situation.
Thanks. Well, this shouldn't take much of your time. I really just have one question.
All right.
I'm having a problem understanding the difference between declarative memory and procedural memory. I think from my notes that they're both examples of, let me see. I have it down here. Declarative and procedural memory are 2 broad types of memory circuits in long-term memory.
That's right, but you need to distinguish between them.
Exactly.
Okay, well, declarative memory is a memory that links us to a fact, like a name or a date or even an experience.
So when I remember a professor's name when I see him, that's declarative memory?
Yes, at its most basic level it is. But declarative memory also includes problem solving. Like today, when you decided to bring your daughters to my office, you were using declarative memory to access previous experiences and facts that would allow you to make a decision.
Oh, right. I remember your example in class. That makes sense now. You were talking about problem solving by recalling experiences. But wasn't that episodic memory?
Very good. Yes, it's called episodic memory. But declarative memory includes episodic memory, which is the ability to access prior experiences or personal episodes in our life, usually for the purpose of making a decision or solving a problem. So episodic memory is a subcategory of declarative memory, so to speak. And semantic memory is just the storehouse of facts that we have in our memory circuits.
Which is also a subcategory of declarative memory?
Precisely.
Okay, then procedural memory doesn't include facts or experiences.
Not directly, no. Procedural memory refers to skills that we've learned and are now remembering in order to perform the skill without really thinking much about it. Like, for example, riding a bike, or do you play a musical instrument?
Piano, sort of. Not really.
Okay. Well, when you ride a bike then, you aren't thinking about the name of every part of the bike and how to use the handlebars or the pedals, or at least not consciously.
No.
But at some level, you are remembering how to do these things, so you're using your memory.
And that'd be procedural memory.
Yes, it would.
Okay, then. That's why you said that declarative memory can be more rapidly learned, but it can also be more rapidly forgotten. Because a fact can come and go in the memory. But procedural memory takes repetition and practice, so it's harder to unlearn. I'm not saying that very well.
But you have the idea. Often with declarative memory, you're consciously trying to remember. But with procedural memory, you're performing a skill without consciously trying to recall how, without each step in the process.
That's what I mean, but...
Yes?
Well, I was thinking about language when my girls were learning to talk.
Oh, I see where you're going. You want to know whether language learning is declarative or procedural.
Yeah.
What do you think?
I was thinking that maybe it's both, because you have to memorize vocabulary, but eventually it's more like a skill, like riding a bike, because you don't think about each individual word. It's more automatic. Do you see what I mean?
A very good analysis. I think you've got this.
Okay. Well, thanks a lot.
And if you ever need to ask me a question and it's hard to get in to see me, just drop me an email.
I thought about that, but...
Look, I'm always glad to see you, but I answer a lot of questions like this by email every day. And if it's easier for you, that's fine with me.
That's very kind of you. Thank you so much.
1. Why does the woman go to see her professor? Two. What do semantic memory and episodic memory have in common? Three. When the professor gives the example of riding a bicycle, what kind of memory is he referring to? Four. Listen again to part of the conversation, and then answer the following question.
Do you see what I mean?
A very good analysis. I think you've got this.
Okay. Well, thanks a lot.
What does the student mean when she says this?
Do you see what I mean?
Five. What does the professor suggest?
Listening 2. History class.
Listen to part of a lecture in a history class.
Frontier home design in the United States was greatly influenced by the provisions of the Homestead Act of 1862. The legislation gave settlers the right to open land, but mandated that homesteaders build a structure that was at least 10 by 12 feet and included at least one glass window. And they had to live on their homestead and improve the land for 5 years before their claim was recognized. Of course, when they first arrived, most homesteaders lived in their wagons or pitched tents until they filed claims and planted crops. And even then, knowing that fully half of the homesteaders wouldn't make it through the 5 years required to complete their claims, homesteaders tended to view the construction of their homes as semi-permanent dwellings. More likely, they'd build something better later or try to improve on what they'd built initially if they made it through the first 5 years. So, in addition to the requirements in the Homestead Act, the settlers needed a home that was easy to build, cheap, and maybe even disposable. Well, the log cabin's the construction that comes to mind when we think of Western settlements. But the plains and the prairies had so few trees that log construction was almost impossible. So the sod house was a practical solution for homesteaders on flat, treeless land. So how do you build a sod house? Well, first you wait for a rain that makes the earth soft. Then you use a sod cutter to form sod bricks about 2 or 3 feet square and a few inches thick. Then you stack the bricks to form walls and weave branches or twigs and grass into a roof that's finally covered with sod as well. Now, there were tremendous advantages to this type of construction. In the first place, it was very cheap. There are journals from the 1800s that document construction prices at about $2.50. And most of that was for the glass window. And it took very little time to build, probably a day or two, and the thick walls actually kept the house quite cool in the summer and fairly warm in the winter. If a better home could be built later, the sod house would simply dissolve into the soil. But there were serious disadvantages as well. Even well-built roofs leaked onto the dirt floors, forming mud puddles, and sometimes the roof even collapsed from the water weight. Or in dry spells, the dirt crumbled from the roof into the home, not to mention the infestations of insects and even snakes that inhabited the dirt walls. So, those settlers who arrived in wooded areas opted to build log cabins instead of sod homes. Like the sod construction, the log cabin could be built in a few days using simple tools, often only an axe. But it was much more comfortable. There's evidence that the first log cabins were introduced by Swedish settlers as early as the 1700s, but other immigrant settlers quickly adopted the construction. First, you build a foundation of rocks to keep the logs away from dampness that might cause them to rot. Then you cut down the trees and square off the logs, cutting notches in the top and bottom of each end so they could fit together when they were stacked at the corners. And it also had the advantage of assuring structural integrity. And there were several types of notching techniques that were used, depending on the skill of the builder. In any case, with notching, no nails were required. And that was good, since nails had to be shipped into towns and then transported out to the new settlements. But there were gaps in the walls, so these had to be filled by a technique called chinking. In chinking, grass, hay, moss, and mud were worked into rolls about a foot long and maybe 4 inches wide, and then they were inserted into the cracks between the logs. These rolls were commonly referred to as mudcats and were very effective in keeping out the cold and keeping in the heat. Of course, the tighter the logs, the fewer chinks were required, and that's important because the chinks were the weakest part of the cabin. And with the expansion and contraction that resulted from freezing and thawing, well, chinking tended to deteriorate and needed constant maintenance and repair. Okay, there was usually a stone or brick fireplace along one wall, and the roof was usually made of wood shingles. So you can imagine this was quite an improvement over the sod house. The advantages were that the home could be kept clean. Even though the floor was usually dirt or gravel because flat boards were difficult to obtain, it was still an effective shelter to keep out the rain and dust. Later, at the end of the 1800s, when the railroads brought materials such as asphalt shingles, tar paper, and finished boards to the frontier, the sod house was abandoned for one-room board shanties covered with tar paper. Whether this was an improvement is subject to debate. For one thing, since they were often built without foundations, the harsh winds of the prairies literally blew the shanties away. Still, many settlers considered the shacks preferable to the old soddies, even though they weren't as easy to heat and cool. To go back to the log cabin for a minute, the effect of new construction materials on the log cabin was aesthetic, as well as practical. The logs were often covered on the outside by finished boards and on the inside with plaster, which gave the cabins a more finished look and improved insulation. And by this time, the old one-room 10 by 12 was also being replaced with larger homes with several rooms. The frontier settlers had weathered the hardships of their first 5 years. They'd received their claims, and they and their homes were a permanent part of the great Western expansion.
6. What is the lecture mainly about? 7. How does the professor organize his lecture? 8. What does the professor imply about construction materials for early homes? 9. What is the evidence for the inexpensive price of a sod home? 10. Listen again to part of the lecture and then answer the following question.
Later, at the end of the 1800s, when the railroads brought materials such as asphalt shingles, tar paper, and finished boards to the frontier, the sod house was abandoned for one-room board shanties covered with tar paper. Whether this was an improvement is subject to debate.
Why does the professor say this?
Whether this was an improvement is subject to debate.
(11) In the lecture, the professor identifies attributes for different frontier homes. Indicate whether each attribute refers to a sod house or a log cabin. Click in the correct box for each phrase.
Listening 3, Geology class.
Listen to part of a discussion in a geology class.
The exploitation of minerals involves 5 steps. First, you have to explore and locate the mineral deposits. Then you set up a mining operation. Next, you must refine the raw minerals and transport the refined minerals to the manufacturer.
Excuse me, sorry, I only have 4 steps. Could you...
Oh, sure. That's exploration, mining, refining, transportation, and manufacturing.
Thanks.
So, each of these activities involves costs. There are costs associated with them, and the costs can be economic, but not necessarily so. Mineral exploitation also has environmental costs associated with it. For example, the exploration stage will clearly have a high economic cost because of personnel and technology, but the environmental cost will probably be quite low. Now, why would that be, do you think?
Because you aren't actually disturbing the environment, you're just looking. I mean, after you find a mineral deposit, you don't do anything about it at that stage.
Right, so the environmental cost would be low. But what happens when you use up all the resources that are easy to find? Then what?
Then the costs go up for exploration.
Which costs?
Well, probably both of them. But I can see where the economic costs would increase.
Okay. Let's say, for example, that some areas such as national parks or historic reserves have been off limits to exploration. What'll happen when we use up the minerals outside of these areas? Remember now that these are non-renewable resources that we're looking for.
Then there'll be a lot of pressure, to open up these areas to exploration and exploitation.
Probably so. And that means that there could be a high environmental cost. Any other options?
Find an alternative.
Yes, you're on the right track.
Okay, find an alternative. A substitute, something that'll substitute for the mineral. Maybe something man-made?
Good. That'll involve a different kind of exploration. Again, with economic costs. I'm talking about basic research here to find synthetics. But let's go on to the other steps and we'll see if we can pull this all together. How about mining? Now, we're looking at high environmental costs because of the destruction of the landscape and the accumulation of waste products that have to be dealt with. Air and water pollution is almost always a problem. Any ideas on refining?
Wouldn't it be the same as mining? You'd have high costs because of labor and equipment, and there'd be problems of waste and pollution, like you said.
True. And in refining, well, that often involves the separation of a small amount of a valuable mineral from a large amount of surrounding rock. So that means that refining also carries the additional cost of cleanup. And don't forget that it's often difficult to get vegetation to grow on piles of waste. In fact, some of it, the waste piles, they can even be dangerous to living creatures, including people, not to mention the appearance of the area. So the environmental costs can be extremely high. Isn't it sad and ironic that so much of the mining and refining must take place in areas of great natural beauty?
So you're saying that both mining and refining have heavy costs, heavy economic and environmental costs.
Right. And in both mining and refining, you'd need transportation to support the movement of supplies, equipment, and personnel. But after the minerals are mined and refined, then transportation becomes even more essential.
And I was just thinking that in addition to the economic costs of the transportation for trucks and fuel and labor and everything, There could be. There might be some construction, too, if there aren't any roads in or out of the area.
And that would mean...
That would mean that the landscape and even the ecosystem for the plants and animal life could be altered. So that's an environmental cost.
It is indeed. Good point. That leaves us with manufacturing. After we find it, mine it, refine it, and transport it, we still have to manufacture it. What are the costs associated with that? Well, construction again for factories. Then there'd be energy costs, technology, and labor.
So all that's economic. No environmental costs in manufacturing, then?
Well, yes, there are actually. Pollution's often a costly problem for manufacturing plants.
Oh, right. I was thinking of the natural landscape, and the manufacturing is often positioned near cities to take advantage of the labor pool. But cities have the environmental problems associated with pollution. So every step has both economic and environmental costs then.
Right.
12. What is this discussion mainly about? (13) According to the professor, what are two problems that can be anticipated when roads are cut into an area for mining? (14) Listen again to part of the discussion and then answer the following question.
And I was just thinking that in addition to the economic costs of the transportation for trucks and fuel and labor and everything, there might be some construction too, if there aren't any roads in or out of the area.
And that would mean...
Why does the professor say this?
And that would mean...
15. What option is proposed as an alternative when all of the mineral resources in easily accessible locations have been depleted? (16) What does the professor imply about the environmental costs of mineral exploitation? (17) What does the professor want the students to do in this class session?